In this example, we will learn how to graph a piecewise function. So if we look at this function, we have three different pieces to this piecewise function. The first piece, x squared minus 4, only happens when x is less than -2. The second piece is the function of 4, a constant function, and it only happens when x is equal to -2. And the third piece of the function is 1/2 x minus 3, and that piece of the function happens when x is larger than 2. Now, if we're graphing a piecewise function, the very first thing that I would always do is try to figure out where does one function stop and where does the next one start. And looking at those inequalities, we can see that that transition point is at x equals -2. That first function will be everywhere on the left side and then stop when x is -2. The second piece is only at x equals -2. And then that last piece is when x is larger than -2. So if we know that transition point, then we can be able to figure out where those endpoints are for the graph. So to help us out here, I'm going to create a table of x's and y's so that we can keep track of the different points on this graph. Now I'm going to split this up into three different sections to represent the three different functions that we are graphing. So the first one here, I'm going to substitute in a -2 so that I know where this function ends, that x squared minus 4 ends. So if I square the -2, I'm going to get a 4. So square -2 and then subtract 4. 4 minus 4 ends up giving me 0. So that first point there on our graph is going to be at -2, 0. Now that's not going to be a solid circle though, because x didn't equal -2 for that function. That's just a boundary. So we'll come back to that point here in a second. For the second one, if I let x equal -2, my y value is going to be 4 because that second function is a constant function. No matter what x is on that piece, it's just going to be 4. There's no change, always going to be 4. And then the last one, if I substitute in a -2, I will get a 1/2 multiplied by the -2 and then minus the 3. So evaluating that, 1/2 times -2 is -1, minus 3 more is -4. So we got ourselves 3 points on this graph already. Let's go ahead and put them onto a coordinate system. So left 2 and nowhere up and down, we decided was an open circle. So my first coordinate's right there. My second coordinate was at -2 and 4. So I'm going to go up 4 from that on the y-axis and put in my second point. And then my third piece was at -2, -4. So I'm going to go down 4 and left 2 and put another open circle to represent that third piece to the graph. So the black open circle is where our first piece of the graph ends. The red circle, red point, is our second piece of the graph where y is equal to 4. And then the green open circle is the starting of our third piece of the graph. Now, if we want to fill in the rest of this graph, we could really choose a couple more values of x to plug in. So for this first piece, I'm going to choose anything that's less than -2. So maybe I plug in a -3 for that. -3 squared is +9. +9 minus 4 is 5. So if I add another point to my graph, I'm going to go to the left 3 and up 5. And I recognize that an x squared minus 4 is a parabola, so I don't want to connect these up with a straight line. I'm going to connect these up with a curve so that it looks like a parabola. But I'm only going to connect it up on the left side because I can only graph according to what the inequality says. and that's when x is less than -2. So that's the left side of -2. Now for the second piece of the graph, it only happens at one x value, when x is -2. And we've already put that point on the graph. -2, 4 was that coordinate. So that second piece is done. And then the third piece appears to be a linear function. It's 1/2 x minus 3. So I could either use the slope to help me find another point going up 1 and to the right 2, or I could choose another value of x to plug in to figure out another point on the graph. I'm going to plug in a 0 just so I know where it crosses the y-axis. 1/2 times 0 is 0. Minus 3 would give me a -3. So 0, -3 is going to put me right on this y-axis. And then I'm going to connect those up in a straight line going in the direction to the right because x is greater than -2, which means we're on the right side of -2. So the three pieces to this function, we have that quadratic or that parabola shown in black for that first line, and that's only happening when x is less than -2. We have the constant function, which in this case is just a single point because it's only when x is equal to -2. And then we have our linear function that has a y-intercept of -3, slope of 1/2, and that's only happening when x is greater than -2. So the first thing we did, we found those transition points where the inequalities and the equations show. So that first one says it's only less than -2. So we found that boundary. What's happening at -2? The third one, same thing. X is greater than -2. We want to know what's happening there. So we went ahead and found what's happening at that point. And we left those open because they're not equal to -2 there. But we were able to put a closed circle on that second function because x does equal -2. So find your transition points, plug in a couple more coordinates to determine where it's going from there, and then connect them up in the shape that the function is, and that is our piecewise function.